Hi everyone, this is Studio Digital Resin and welcome to this demonstration of AGX variables. This is just a follow-on from my intro to GX variables video, where I will show you the application of using GX variables to control or to help you in creating your geometry a lot quicker, and then managing your geometry after you've created it. So what I'm going to do is going to apply this to the Brasilia National Stadium demo, where I will show you some new features of arcs and rectangles, where what I will show you is the ability to create rectangles in this fashion and the arcs across these bays, these trusses. I'm going to try and keep this as quickly as possible, as short as possible, just to show you the use of the variables. So I will create this circle here and these two outer circles here. I will create these rectangles, all 96 of them, and then half of that of these bays, because these bays straddle every second rectangle, and I don't think I will have enough time to go any further than that. Right, so let us start. So first of all, let me change my point style. Right, so I'm going to create a point at the origin, 0, 0, escape. Now I'm going to create a rectangle which will serve as the pitch, the football pitch, just as a reference size. So you can either choose rectangle from up here or type in GX rect. So what I will use is by center point, width and height. So I'll choose my center point. So my units will be 68 meters wide and I think make it 110 meters high. Right, so it's more or less the dimensions of most football pitches. Right, so let's go and create some variables so that we can control our football pitch size. So the width and the height of a rectangle are doubles. So just for a short name I'll put W. The max, anything up to the value or greater, 68. Create another double, call it H for height. You can call it whatever you like. 110. So you won't be able to go above 110 if you've set your max to be 110, or below 0 if your minimum is 0. This is just to help you in controlling the sliding scale, which will come in a later release, that you can in real time slide a scale from left to right, and you can visually see your changes happen as you slide that scale across. At the moment you have to hit OK or update once you change the value. Okay, so let's go back to our rectangle. We've got one rectangle, a GX rectangle that has one AutoCAD entity. So you can see here that these are the values that you typed in, but you could have just put in H or W. So the names of your variables can be replaced, can replace the values that you've typed in, and hit update. Right, so nothing changed because those variable values were the same. But if we jump back to width, for instance, and change that to 50, hit update, and that will obviously update. So let's put that back to 68. Right, so now I'm going to define some extra variables which will be necessary. An integer, I'm going to call this base. 100, and the value will be 96. So we're going to need 96 bays. The bays are the actual, they kind of represent the sides of a polygon, if you like. So if you wanted to divide a circle by 3 points, you would in fact just have 2 bays. So there'd be a point over there, a point in the middle, and a point at the end. That creates 2 bays. So we need 96 bays. We also need a radius for the smaller circle, a radius for the larger circle, for the second largest circle, and a radius for the third largest circle. So radii are specified as doubles. I'll call this R1. Maximum will be 100, and the radius can be probably, might just be the actual width of the football pitch itself. I'm not too sure, but it may be. Let's create another one. Radius number 2. Maximum of 100, and the radius can probably be 80 meters. Call the next one radius 3. Maximum of 100, and we can make it 10 meters greater than the second largest radius. Right. So we have a set of variables which we can immediately use to start creating the geometry that we need. Let's go back to entities. Let's create our circle, gxcirc, by center point and radius. So we select our center point. Our radius will be R1. Enter. A 0x offset, a 0y offset, and a z offset, which we will change later on as well. So this is going to be the height of the circle above the center point. Okay. You will see that they all lie on the same plane. Create another circle by center point and radius. R2. 0 for now. Create another circle. Choose that center point, and the radius will be R3. And hit enter for the defaults. Okay. So now we have something similar. Now we need to subdivide these circles into points so that we can use those points to create lines from start and end point. GX point. So you choose by base on a curve. Anything that is a line, a circle, a rectangle, or a spline, or an ellipse is called a curve. So we'll choose circle number 1. It asks you for a number of bays, defaults to 2. So we will put in our variable name, bays. Include the start, yes. Include the end, yes. Go again. By base on curve, choose our second circle, 96, oops, sorry, base, the variable name, yes, and yes, and the last circle, number of bays will be our base variable name. It'll be the start, it'll be the end. I'll explain that start and end later on. Right, so now we have our subdivisions. All lines need a start and an end point. So let's go ahead and create our line, our start point, end point. Now this point here is called gx point. That's what it's not appearing. Oh, but it's probably called gx point 4. Yeah, there are 97 of them. Gx point. This will be gx point 2. This will be gx point 3, and this will be gx point 4. Gx point 4 controls all of these AutoCAD points. Gx point 3 controls all of these AutoCAD points, and so on. So when when AGX asks you for a start point, if you select a point which is a multiple point, it knows what to do. So I've chosen this as the start point, and this one is the end point. Don't worry about skip over start and end. I'll explain that to you later on. And there you go. It knows immediately that this is the sort of thing that you want to do. You didn't have to go ahead and select each and every point. It knows immediately that this is a GX entity, and it knows that it's got multiple points, and it knows what to do. Right, so now let's do that again for the last two, and we will need lines to create our rectangles. So choose this one, that one. Okay. Now you may be wondering, okay, now what do we do with the fact that we've got multiple divisions on the outer circles, but there's a skip of lines on the inner ones. So imagine there's a line here, which is our line, another line there, and another line there in the middle. So somehow there's a line here because we are sharing the same point object to create these lines. Previously what you had to do is you had to create another GX point with a smaller bay count and then choose that one to create that same sort of effect. But now you have the option, when you select your line, you've got endpoint skip, hop over, and start point skip. Start point skip specifies how many of the points you would like to skip before it starts to create the lines. And it's the same for endpoint skip, so it stops the number that you put in here before it reaches the end of the points along that curve. And hop over tells it how many points to hop over when it starts to create the lines. So if you specify 1, and what this will do is, oops, okay, there's something I need to fix there. So I've specified 1, and we hit update. Right, so you can see what it did there. You get a line on the start point and end point. The next pointer goes along, it says, oh, I've got to hop over 1, and then it goes to the next one. So that's quite a useful way of not having to create multiple point objects just to get the same net result. Okay. Now, let's see here. We've got 1, 2, 3, 4, 5, 6, 7, 8 bays and 1, 2, 3, 4, 5, 6, 7 actual arcs. So let's create another variable, and I'll call it arc bays. We only need 8 bays, and the value will be 8. Okay. Come back to entities. Now we're going to create another point by bays on a curve. If I select this line this line belongs to the same controlling GX entity. So I just need to select any of them and it will know, oh, I've got multiple lines, and I'll know what to do. So I'll pick one, enter the number of bays, I'll put arc bays, include the start, no, include the end, no. The skip over also gives you the same power. Right, and let me show you what it has done. So it has divided each line into 1, 2, 3, 4, 5, 6, 7, 8 bays, and it's put a point in between each bay, and the skip end and skip start, or sorry, the include end and start means that if you said include the start, it would put a point at the beginning. But we don't want that, because that's how it is in the picture, and this gives you the ability to do that. Right, so now we have our points which we'll use to create the arcs which sit on this section of the design. So how do we do this now? Right, so this point now is what is called a point matrix. So there are X number of points along X number of rows. So it's a matrix of points that has rows or columns and rows. So the command for arc is gxarc, and we will choose number 4 by matrix point, start and end height. It will know that the point that you choose is a matrix point, and if it is not a matrix point, then it will not be able to create it. So it knows what to do when you've selected a point that has rows and columns. So any of these will do, they all belong to the same GX point entity. So the start height means that the way it creates the arc is it creates a virtual line in between, subdivides it in the middle, and then creates a vertical entity or vertical point based on your height, and that's how it creates the arc. So what will happen is that you can, if you've got a lot of arcs going down this way, or a lot of points going down in this direction, you may want them to start at a certain height and end at a certain height. So I'll just say let's start at 3 meters and end at 1 meter, and hit enter, and there you go. It has now created arcs on the point matrix. So if I were to draw a line in between here and then draw a vertical line, that would be 3, and the next one would be 2.9 or so until the final arc, which will be 2. So that's your start and your end height. I'll give you an example of how that would look if you were to change it. The selection process, it takes a bit of time because there are quite a few of them. So there's one GX arc object which owns 336 AutoCAD arcs. Okay. So we have here a start height and an end height. If I move that to, change that to 5, you hit update, you will see straight away the effects. Put it back. Right. Hit escape. Now, the rectangles. Okay, so the rectangles kind of have an offset from the edge, a very small offset, I presume. So what we can do is we will use the gxrect command by midpoints and width. So it allows you to choose 2 points which will be the midpoint of the top and the bottom edge of your rectangle, and you specify a width. That's all you need to create a rectangle, really. You don't need 4 corners, you can just use midpoints and a width. So I could use this as the top midpoint and this as the bottom midpoint, but we don't have the offset ability. So if I create another point by parameter on a curve, the parameter is a percentage of the length of the curve. So if I pick this curve, I want it to be 0.1 away from the start. So this is now a 1/10 along the distance of the curve. We do it again, and we want it to be a 1/9 along the distance of the curve. Right. Let's go to GX rect by center point, by midpoints and width. Pick the top midpoint, can be any of them, the bottom midpoint, and our width, 5 meters maybe. Right, and there's the result. Let us actually create a width variable. RW, rectangle width, max is 5, and it obviously needs to be a bit smaller, so 3. Go back to our rectangle object. So this is now the value 5, but if we change to RW, hit update, and that will change. Okay, 21 minutes. Right, let's do the offsetting. So instead of creating a center point being X meters above the ground, you can just use the offset. So I will just presume that smallest circle is, say, 25 meters above the ground. So now you will see that it has pushed itself vertically by 25, and I presume that I have seen this image before where there is a slight slope on these two outer circles. So this one can be 28, so that's more obvious, and that one will jump up. Select this one, and I think there's a slight slope, so we can make that 20. Now let's make it 30. Okay. So if you have the ability to test your design quite quickly, should you need to play around with the slopes and just to see how it works without having to manually readjust tons and tons of geometry, doing this the unparametric way. And you could also adjust the number of bays, the number of arcs that you want, the number of rectangles, all that quite quickly. Let me show you. So we've got 96 bays. If I wanted to drop this to 50, for example, and straight away you can see the visual difference or the visual impact of your design change. Right, and there you have it. I'm not going to spend any more time on this because it's been quite a long demonstration, and I hope you've found it useful, and maybe you can see what you can do in a very short time with parametrics. So this was Studio Digital Resin, and thanks for watching. I'll catch you on the next one.